Yes, good evening, my dear students. Come to the live session, all of you. So today we are going to discuss the paper discussion. So which is we are conducted in our exam and our college. So in that, some of the most important questions, most expected questions we'll discuss. Some of the most expected questions we'll discuss. Yeah. Yes, look at. See, the question is when 0.6 grams of urea dissolved in, when 0.6 grams of urea dissolved in 100 grams of water, 100 grams of water will boil at then kb for water it is equals to 0.52 Kelvin kg mole inverse they're mentioned. Then boiling point of water is mentioned. Boiling point of water equals to 100 degrees Celsius. So this is given in the data. Then options are given: 372.48 kelvins, 273.52 kelvins, 373.52 kelvins, then 273.052 kelvins. There's 2 or 4 options are given. Observe it carefully. What is the question? When 0.6 grams of urea is dissolved in 100 grams of water will boil at nothing but boiling point of solution. They're asking boiling point of solution. Boiling point of solution is TB. Then boiling point of pure water is mentioned, that is 100 degrees Celsius. Then this is actually solution if you want to find out means. Then elevation in the boiling point you have to find out. Elevation in the boiling point formula is Kb into Wb into 1000 divided by then say Mb into that is Wa. Sir, Mb, Wb is what? Weight of solute and molecular weight of solute. Wa is what? So weight of solvent. So delta Tb it is equals to Kb is nothing but 0.52. Then into weight of solute 0.6 grams is mentioned, right? 6 grams is mentioned. Then divided by 1000. Then divided by molecular mass of urea is 60. Then mass of the solvent, that is water. So 100 grams of water they are mentioned. So 100. So 100, 2 zeros cancel. Then 0.6 into that is 10, 6 outundi. So 6, how many times it will go? 60 times, 10 times. So then, so 0.52 divided by 10, 0.52 divided by 10 equals to 0.052. Delta TB it is. Then delta TB it is equals to what I told, boiling point of solution minus then boiling point of pure water. So is that visible, my dear students? So please tell me. Yes, is that visible? Okay. So boiling point of solution minus boiling point of pure water. So delta TB value you got it is 0.052. Then TB you want to find out. Then minus what will be there? T naught B 100 degrees Celsius. Then when it is sent that side, then you can get it is 100.052. So it is in the degree Celsius. Then in case if you want to convert it to the kelvins, then you can get it is 373.052 kelvins. So that is 373.052 kelvins is the answer. Okay, understand? So this is one of the most expected question for the coming EAP set examination. Okay, clear, my dear students? The one more question will go. So better to note along with me whatever the expected questions are there. Only expected questions we'll discuss today, right? The next expected question is So this is 273 ml of gas at STP. It is from states of matter. 273 ml of a gas at STP was taken to 27 degrees Celsius and 600 mm of Hg. 600 mm of Hg. Then pressure, the final volume of gas would be pressure. The final volume of gas would be the final volume of gas would be. This is the question. This is the question actually. See, look at my dear students. For this question, options are given. Sir, option 1, 273 ml. Then option 2, 300 ml. Then option 3, 380 ml. Then option 4, 586 ml. Yeah, look at. Say, and this first one is STP conditions are mentioned. STP. Then second one is mentioned another conditions what are. So temperature condition, that is 27 degrees Celsius, nothing but plus addition of 273, then you can get 300 kelvins. Then pressure is mentioned other, that is 600 mm of Hg. Then yes, look at my dear students. Then what they're asking, volume they're asking, volume of the solution. So STP conditions దగ్గర వాల్యూమ్ ఎంత ఉంది, 273 ml ఉంది. STP కండిషన్స్ అంటే టెంపరేచర్ ఎంత ఉంటుంది, S273 ఉంటుంది. Then pressure ఎంత ఉంటుంది, 1 atmosphere will be present. 1 atmosphere nothing but how many mm of Hg, 760 mm of Hg, my dear students, 760 mm of Hg. So just to take it as V1 T1 P1, then T2 P2 V2. So P1 V1 divided by T1 equals to P2 V2 divided by T2. This is the formula. From this, what you have to find out? So V2 you have to find out. V2 equals to P1 V1 divided by T1 into then T2 divided by P2. This is the formula. See, look at all these from the V2. V2 it is equals to P1 V1. What will be there? P1 760 into then V1 T1 273, then divided by 273. So into then T2 divided by P2. So T2 will be, what will be there? 300 divided by 600. Yeah, look at. Say 273 cancel both. Then say here 2 zeros cancel. 3 1s, then 3 2s. Then 2, it will go that 380 times. So 380 ml is answer. So this is 380 ml answer. Understand, my dear students? So what formula we have to use? P1 V1 divided by T1 equals to P2 V2 divided by T2. That formula you have to use. So this is second most expected question from it. So they are given frequently in the grand test examination. So that is what we are discussing. Then one more question. Look at, my dear students. Then RMS velocity of hydrogen gas. RMS, that is the RMS velocity of the question is the RMS velocity of H2 gas is 2400 meter second inverse. Then at room temperature, the RMS speed of oxygen gas would be at room temperature, RMS velocity of O2 gas would be. This is the question. So look at, they're mentioned option 1 400, option 2 300, option 3 600, then option 4 1600. See, look, my dear students. So actually this is belongs to then RMS speed, RMS velocity is Graham's law of diffusion also. Then Graham's law of diffusion, what it will tell? Rate of diffusion of a gas is inversely proportional to its molecular mass. From this we can say Then R1 divided by R2, it is equals to square root of, sorry, M2 divided by M1 you can take, right? Clear, my dear students? This is from Graham's law of diffusion of a gas. Then R1, so RMS velocity or diffusion of a gas, rate of velocity of a hydrogen gas. Hydrogen gas, how much is given? Then 2400, right? Then R2 you have to find out. Then, so R1 is what? Hydrogen gas. Then R2 is what? Oxygen gas, O2 gas. They are mentioned O2. So O2 molecular mass you have to take, that is 32. Then divided by hydrogen molecular mass 2. So 2 1 so 2 16. So 16 root 16, how much you can get? 4. So 4, right? Then 2400 divided by R2. So R2 is required, means R2 equals to 2400 divided by then 4. So 4, how many times it will go? 600. Then 600 meters second inverse is answer. So 600 meters second inverse is answer. Okay, clear, my dear students? This is based on RMS velocity. Next, one more question is given, the most expected question from this. Yes. Yes, look at, my dear students. The question is, so A plus 3B, they are mentioned as gases, these are. Then this is 4C, even this is also gas. Initial concentration of A is equals to that of B. Initial concentration of A is equals to that of B, is equals to that of B. The equilibrium concentration of A and C are the equilibrium concentration of A and C are equal. Kc of the reaction will be this is the question, my dear students. See, look at the options. Option 1, that is 0.08, then option 2, 0.8, then option 3, 8, then option 4, 80. See, observe the question carefully. What will be there, man? See, equation, whatever they are mentioned, that equation I have to take first. So A plus 3B gives rise to 4C. This is the equation. So in this equation, initial concentration of A equals to that of B, nothing but. So when time t equals to, that is initial concentration of A is, in case if you take 1, even B also 1. Then the equilibrium concentrations of A and C are equal. See, first at equilibrium, in case what happens? See, 1 minus alpha, then this is 1 minus alpha. Then, see, look at, so here 1 minus alpha, if you take here 1 minus 3 alpha, I have to take because of stoichiometric coefficient is 3. Then here the 4 alpha I have to take because of stoichiometric coefficient is 4. Clear, my dear students? Then they are mentioned the equilibrium concentrations of A and C are equal. Say 1 minus alpha, that is equals to 4 alpha, they are mentioned. So 1, it is equals to 5 alpha. Then alpha equals to 1 divided by 5. So alpha value you got, it is 5. Then concentration of A you can get now. Concentration of 1 minus alpha. Then 1 minus, that is 1 divided by 5, nothing but 0.2, right? Yes. So 0.2. Then if you take, then you can get it is 0.8. Then same like that, concentration of B equals to 1 minus 3 alpha. So 1 minus 3 into 0.2. Then 0.6, 1 minus 0.6 equals to 0.4. Clear? Then concentration of C equals to, so 4 into alpha, so 4 into 0.2. 0.2 equals to 0.8. Yes, so all these concentrations if you find out. Then next, see, look at Kc value, how to find out. The Kc equals to, from this, so C power 4 divided by A into B power 3. See, C concentration, what will be there? 0.8 whole to the power 4. then divided by A concentration 0.8 into, then here 0.4 whole to the power 3. Clear? Clear? See, look at 0.8, 4 times will be there now, 0.8 into 0.8 into 0.8 into 0.8, then divided by 0.8 into 0.4 into 0.4 into 0.4. Yes, 0.8, 0.8 cancel. So 0.4, ones, twos, then ones, twos, then ones, twos. So 2 into 2 into 2. 2 to the 4, 4 to the 8. So 8 is answer. So 8 is answer. Clear, my dear students? This is one of the most expected question. They're asking frequently. This is calculate the equilibrium constant Kc. Calculate the equilibrium constant Kc. They're asking. Oh, nice. Very good. Hide me what? Good evening, sir. Yes. Yes. Next most expected questions from the EAP set examination. See, look, my dear students. So next one, that is, so this question is frequently they're asking, my dear students. The question is, what is the pH of? What is the pH of 0.1 normality of CH3COOH solution? They're asking like this question. Then ionization constant Ka is mentioned, that is 1.8 into 10 to the power of minus 5. Then what is the pH? pH you have to find out. So one is 2.87, they're mentioned option. Then option B 3.39, option C 3.9, option 4 4.72. Yes, look at CH3COOH is a weak acid. So this is weak acid. Weak acid pH value, if you want to find out, pH of weak acid equals to, the formula is 1/2 into pKa minus log C, my dear students. See, look at, then what is the formula? pH equals to 1/2 into pKa minus log C, right? Say, look at 1/2 into log A, log pKa, what will be there? So pKa, what will be there? So pKa not given, Ka value is given. So pKa, if you want to find out, pKa equals to minus log Ka, minus log Ka value 1.8 into 10 to the power of minus 5 is there now? Yeah, 5 minus log 1.8. So log 1.8 value, that is 0.25 can get. So 0.5 you can get means 4.75 can get this. So here pK value 4.75. So minus log C. So that is 0.1 normality, nothing but 10 to the power of minus 1, right? See, 1/2 into 4.75 plus. So this is minus into minus 1 plus 1, log 10 value 1. So 5.75 divided by 2 you can get. Then the answer is 2.87. You can get 2.87 for this pH of weak acid, my dear students. Okay, this is very, very, very important. So pKa, in case they are not mentioned in the question, so pKa equals to minus log Ka. You have to take the formula. In the place of Ka, you have to substitute. You can get pKa value. So they are asking frequently this type of questions. What is the pH of weak acids? Weak acids ఇచ్చినప్పుడు ఖచ్చితంగా dissociation constant Ka value అందులో మెన్షన్ చేస్తారు. Yes, who's that? I'm taking classes, man. Why you are coming inside? Huh? Yes, next most important question, my dear students. That is, Yeah. The number of moles of K2Cr2O7 reduced by 1 mole of SN plus 2 ion. The number of moles of K2Cr2O7 reduced by 1 mole of 1 mole of Sn plus 2 ion is Sn plus 2 ion is. This is the question, man. This is the question. Options are mentioned. Option 1 by 3. Option 2 3. Option 3 1 by 6. Option 4 6. Like this is given. See, look at, in case if you want to get the answer for this, then first you must be know potassium dichromate in the presence of acidic medium, how it will be converted. See, look at Cr2O7 minus 2 can be converted into Cr plus 3 in the acidic medium. We know that. Then same thing, Sn plus 2, in case if it is reduced, Sn plus 2 can be converted into Sn plus 4. Clear? So both, in case both by combined, if you take, then Sn plus 2 can be converted into Cr plus 3 plus Sn plus 4. So Sn plus 2 to plus 4 oxidation number changes are 2. Then here oxidation state chromium plus 6. So plus 6 to plus 3 number changes are 3. But how many chromiums are there? 2 chromiums, so you have to multiply with 2. So then here you can get 6. So once these values are, in case if it is divide, then 2 ones, 2 threes, you have to divide it like this. 2 ones, 2 threes. Then, so whatever the number you got, that you have to multiply with this. So whatever the number you got, that you have to multiply with this. Crisscross method like this. See, look, my dear students, now balance the equation, note it. Cr2O7 minus 2 plus the number when it is multiplied 3 Sn plus 2, then Cr plus 3, then plus Sn plus 4. If it is balanced, here 2 chromiums are there, you have to take 2 chromiums. 3 Sn are there, 3 Sn you have to take. See, look at the total entire equation in R2, Nin R2 balance. See, because this is 1 mole will be there, then it can reduce just 3 moles of Sn plus 2. 1 mole 3 moles reduce cheste. Then 1 mole of Sn plus 2. 1 mole of Sn plus 2 reduced by how many moles of Cr2O7 minus 2? Cross multiplication you have to take. X equals to 1 into 1, 1 divided by 3. Yes, 1 by 3. So 1 by 3 is the answer for this. 1 by 3 is the answer. Clear? Understand, my dear students? Yes. Then next one more question. So all our theory questions will be there. These are the numerical problems they are given in the examination. So next time, so we'll discuss most expected questions from it. Good afternoon, sir. Good afternoon. I am Ram Charan. Yes, Ram Charan. Good afternoon. Okay, thank you. We'll discuss later again.